Welcome to this video. Today we are going to talk about bias and variance, which are considered the building blocks of machine learning. At a very basic level, machine learning is about training a model, using data, and expecting it to perform well on new unseen data. Whenever a model fails to do that, the reason is usually bias, variance, or combination of both. Bias happens when the model is systematically wrong. Bias is error that comes from overly strong assumptions. High bias models cannot capture the real pattern present in the data. Symptoms include high training error and high validation error. More data usually does not fix high bias. Example, true pattern is curved, but the model assumes a straight line, resulting in a systematic miss even on training data. Variance happens when the model is too sensitive to the training data. Variance is error from sensitivity to the training data. High variance models change a lot if the dataset changes slightly. Symptoms include very low training error but high validation error. More data and regularization are the best variance reducers. High variance intuition, model learns noise as if it were signal. We diagnose bias and variance using training versus validation performance. High training error and high validation error indicates high bias. Low training error and high validation error indicate high variance. Low training error and low validation error indicate a good fit. Unstable validation metrics across folds often indicate variance or data leakage. This slide shows model complexity versus error. As model complexity increases, training error decreases. Validation error decreases only up to a point and then increases. The best point is near the minimum validation error, not the minimum training error. High biases, training and validation curves converge at a high error. High variances, large gap between training and validation error, which shrinks with more data. Learning curves help decide whether collecting more data will help. High bias fixes, increase model capacity, add better features, reduce regularization. High variance fixes, collect more data, add regularization or early stopping, simplify model or use ensembling. Always use cross-validation for stable hyperparameter tuning and to avoid test set leakage. Bias and variance are your core debugging framework. Bias means model is too simple, variance means model is too complex. Learning curves tell whether more data will help. Validation curves help choose complexity and regularization. Use numerical thinking, computer error, decompose error, then act. Feel free to ask any queries or give suggestions in the comments and subscribe if you liked the video. Thank you for watching.